Hi, welcome to this screencast on using your computer screen as an Alexa smart home security camera. So my name is Damien Mears. I live in Switzerland. You'll find me at damien.fyi. Um, so whenever I go over to the United States, there are lots of toys, tech toys, that I cannot get here in Switzerland. The Amazon Echo and the Echo Show, not available here. So I pick things up and bring them back. And so I picked up an Echo Show. I also got a Ring Video doorbell security camera. But as I was thinking about setting it up, it occurred to me that actually what I already had in my house, in my office at home, was a computer running some software that shows me various different security cameras I have set up. For a long time I worked from home and it was a little bit creepy hearing noises around, so I just wanted a way to see them around the house. So I have this running permanently. It's an Intel NUC running Windows, and then I just run the security camera software on it. I use that computer for other things as well as a media server and so on. But what I wanted to do was display that screen on my Echo Show as a security camera, so that I could say, Alexa, show security cameras, and it would show the contents of that screen over to there. And that's what I've worked out, and that's what this is about. I'm going to go into the configuration. I'm not just going to show a PowerPoint. I'll actually show the computers that are running and what I'm running on them. So in terms of how it works, the kind of the big picture, we have obviously the Echo Show. We have an Alexa smart home skill. If you're not familiar, if you're not a programmer or familiar with configuring things, this is probably not for you. You'll need some technical knowledge. You'll need to know how to go in and configure a smart home skill. You're also going to need Amazon Web Services Lambda, or something that the smart home skill can talk to handle things like device discovery and camera control. So again, this is some coding. You could probably get away with copy and pasting, but some kind of background in technology would be useful. I'm also running an Ubuntu server. This is actually a MacBook Air, an older MacBook Air that I've just installed Ubuntu server on, and the reason I'm doing that is because I want to run Docker. I've actually installed practically nothing at all on this machine, this MacBook Air running Ubuntu. I've obviously installed Ubuntu, and I've installed the latest patches, and I've installed Docker, and that's it. And the reason for that is that it keeps everything really nice and clean. Whenever I want to install or play around with software, I use Docker. So that's how I'm working. If you're not familiar with Docker, it's a way of essentially, it seems like you're running a virtual machine on top of your Ubuntu computer, but you're not. It's kind of much more closer to the metal than that. Again, you should probably read up on Docker if you're not familiar with what Docker is before getting into this. On the Windows machine running the security camera software, I'm pretty sure this would run on a Mac as well. I've not tried it. I do have a Mac that I now run as a MacBook Air Ubuntu server, but I have another MacBook as well. Anyway, so I run a command on that streams the screen using a protocol called RTSP, which I'd never heard of before starting this little adventure. And inside Ubuntu, inside the Docker machine, I'm running something called a Live 555 proxy server, which is free software, and I'm running something called S-Tunnel. And the reason for that is that the Echo Show has or the Alexa smart home security camera mechanism has particular requirements. It needs to talk using RTSP, which is why I'm using RTSP running on this guy. So this is the command I use, VLC, just a command line command, and it spins up VLC and starts streaming my screen using H.264 as the codec. You don't really need to know anything about that, but that's what it is. 60 frames per second, and it's half the screen size, and it kind of streams to this location. And what I do on my Docker machine or my Ubuntu machine is run Docker running expose a port 443, which is a SSL HTTPS, and I inside my Docker image, which is spun up as a container, it's called Live55 proxy, and you'll see how I build that Docker image, and the content is available online. Anyway, I run that and I tell it to run S-Tunnel, and what that does is wraps a non-secure port so in this case port 80, and wraps it as 443 as a secure port. So basically S-tunnel is, again, you can read it, you just Google S-tunnel, it lets you kind of tunnel or provide a secure port, secure endpoint over a non-secure port. So, and that non-secure port is this proxy server here, Li-Fi 5 proxy server, and so what it does is it talks to the NUC, media NUC, which is running this VLC. It talks on the port here, which is the one that's been exposed by this command, and it essentially proxies that content, and it proxies that content over HTTP, and then S-tunnel kind of packages it over SSL, and that means that I can show it over there. So that's the big picture. I think that's all the slides I have. Yep, it is. So let's go back. Let's go to how this actually works. I'm going to first of all just make a couple of acknowledgements. In order to work out how to do this, I've followed a couple of pages. One was this one here by EM Tunk. I'm suspecting that's not the person's real name, his or hers real name, but that told me how to do part of the story. And then the other person here, I'm guessing is called Sam Machin, possibly. Anyway, they've got a whole thing about how to use a Raspberry Pi and with a camera associated with it, and access that from an Echo show. So those were the kind of starting points that I used. So first things first, I defined my smart home skill. I'm not going to go into the details on this. You can follow the instructions on how to set up a smart home skill. Essentially, you go in and you configure it. It's really a configuration thing. I'm using v3 of the protocol, and it talks to a lambda, which is defined here in AWS Lambda, which is it's kind of like a server running in the cloud, but it just does one thing. It's one particular function, and that lambda. I'm not going to go into the details on this. You can find, if you want the dirty, the real details on it, go to my blog, Damien blog, and you'll find live coding an Alexa smart home skill from scratch in C#. And there I start really from zero. I define the smart home skill. I define the lambda from scratch. So if you might want to watch that first before, or pause this one and watch that one before going into it. So anyway, so I have my smart home skill, and I have my lambda, which I've written in C#. You don't have to write it in C#. You could do Python, you could do whatever Node, I guess, whatever language. I just like C#. And what I'm doing to configure that is I use Microsoft Visual Studio, which is available for free. In fact, there's no commercial software in anything here. I guess the Windows machine I'm using for the security camera software, but that's pretty much it. Anyway, so that's so you will need to configure your a smart home skill, and you'll need to set up the lambda. So the smart home skill is entirely configuration. The smart home skill does involve some programming, so this will all be in my blog post as well, but at damien.fyi, but I'm going to switch over to Visual Studio, and I'm just going to don't worry, there's tons of code here, but it's really very, very straightforward. If you're a C# or .NET programmer, you might wonder where all these come from. Essentially what I do, where all these classes come from, they're things like request and capability and all these Alexa smart home security camera constructs. And what I do is I created my raw lambda, and I printed out what was received, and then I ran that through an online tool that generates C# classes. Again, the blog post I created, I'll handle that. I'll show you how to do that. Creating a smart home skill from scratch. But there are two things that this lambda does or handles. One is discovery, so what cameras are there. So when I say Alexa, discover smart home devices, it'll invoke this. And then when I say Alexa, show security cameras, it'll handle this. It'll invoke this code here. So this generate camera discovery response. That's down here. And so what I'm doing is generating a C# class, which it maps onto a JSON message. And so even if you're programming in Python or Node or whatever, you'll need to do the same thing, which is to essentially generate this structure. There are a couple of endpoint IDs here. I just used a UUID gen command on Ubuntu, and it just generates unique IDs. So don't copy paste my ones. You generate your own ones. Manufacturer name, I could put my own name. Model name, I just made something up, and I've given it the description and friendly name of security cameras. And the things that I guess are important to the capability here, I'm specifying that it does this RTSP protocol, no authorization because I'm sitting inside my own LAN, and no audio. I've not tried audio, maybe polyaudio would work. I'm saying it runs using 8264, and for the resolution, I've taken the resolution that my Windows machine, this guy, the resolution of this monitor, and I've essentially halved it. So that's where that resolution comes from. So that's that. So when I say Alexa, discover smart home security cameras, it'll invoke this and return back a JSON message, which is essentially all of this. You'll find Amazon documentation on creating smart home security camera skills with, I think, examples in Python, so you can copy paste their code and plug it in. There is no C# one yet, so for that you'll need to essentially, well, I'll put this all on GitHub anyway, so you can clone my repository to do this, or generate the C# classes yourself from the JSON that's you're passed in. Anyway, once the security camera has or once the query has happened, once it's discovered, then if I say Alexa, show security cameras, which is the name I've defined here, then it'll invoke this initialize camera streams response, and this is where things become kind of less, or I guess a bit more interesting. First thing is it requires the URI of the machine that I'm using. If I go back to my PowerPoint, to this machine here. So it's, in my case, I've owned the 1l.io domain, so I set up a entry that called MacBook Air Ubuntu that has the private IP address of the MacBook Air machine here. How do I do it? IP ADDR, I think it is. Somewhere here we'll see the private address. Here we go. So if I was to ping this machine, let's see what happens. There we go. It's pinging, but it's actually pinging this machine. So that has a couple of implications. The first is you will need a fixed IP address for your Ubuntu server. So most network software lets you do that pretty easily, or most routers or gateways let you do that pretty straightforwardly. You just say make sure that the MAC address of this machine is always given this IP address. So I configured that in my domain name register. So I use Namecheap. You can use anyone you want to, obviously. So MacBook Air Ubuntu is configured to talk to, or configured with that IP address. So that's I'm kind of winding back the stack. This is my, so that's why that's the IP address, or that's the domain name. It's got to be a public domain name, um, and it's the and it maps to my MacBook Air Ubuntu running locally. I just give the expiration time of 1 day from now. Idle timeout 30 seconds. So I think that means if I'm how long it shows the camera on the Echo Show before it stops. The resolution, this is the width and height, which I just take as what is being requested, and the input, which is what has been defined below. So in my case it's 1920 times 1080 divided by 2 on each, which is the resolution of the Windows machine, and I give my loading image, which I just was I don't know what that's going to show me. Here we go. Just an image I happened to find on the internet. So that's just used. I don't know if I've actually seen that image being displayed, but it's just kind of a loading image. I think it caches the last image that was displayed once you're running the security camera, or once you've actually connected to your security camera, which in my case is my Windows machine. So that's the cloud part of things. I've defined the smart home skill, and I've defined the lambda. Again, I'll put this in GitHub, so you'll be able to see that. So let's go on to my Ubuntu machine. So my Ubuntu machine, like I said, is running absolutely nothing except Docker. So I mentioned before that the Echo Show needs to talk using SSL. It needs to talk using, I think it's RTSP tunneled over HTTPS. So the RTSP is tunneled over HTTP here, and then stunnel kind of packages up over HTTPS. And in order to do that, you need security certificates. You need to be able to, the Echo Show needs to be able to talk to the my Ubuntu machine over SSL. I mentioned before that it's using where's the oh, it's up here. The URI is this RTSP using 443. So I need to set up SSL certificates for this domain. So I used, on my Ubuntu machine, I installed certbot, which is I think an official Docker image. And if I go to my history, you'll see that what I did was requested security certificates for MacBook Air Ubuntu using this command. What that requested me to do is define a text entry in my domain, in my DNS. So if I go back, so I ran that, and it prompted me, for various different things, and then said create a DNS entry with this particular value. And so if I go back to my, I'm probably gonna have to delete all this and start again. I don't know if I'm exposing myself to anything. Anyway, where's my DNS? So that's my text record that I created here, with a value, and that worked. And once I did that, I had to wait quite a long time for the text record to be kind of propagated over DNS, and then I said OK, and it generated a load of files, PEM files, which are contain the security certificate information essentially. I copied them from my certbot container, and I copied them locally, and they're in this folder called certs here, CRTS. And once I'd done that, I created my Docker my Docker image, and I did that using, let me just copy paste the code. So I'm looking at my note. So I did that. Actually, it's not that complicated. I did that using docker build from this current location, and I gave it this tag live55 proxy. So that docker build uses this docker file here. So let's look at that docker file. Alright, it starts here. So this is the docker file I created myself. It starts based off of Ubuntu as a working directory of /app inside the container. So I add that certs file, or certs folder I should say, with all the certs, and I put them into /stunnel. I also add this stunnel configuration file, and we'll look at that in a second. And then I install various packages I need. So I install build essentials, make wget, and stunnel, the stunnel package, standard package. I then run this command here, which pulls down the live55 proxy server, untars it. This is important. It replaces all instances of proxy stream with H.264. The reason it does that is that the Echo Show, the Alexa Smart Home Skill mechanism, requires the URL to have H.264 at the end of it. And if I just go back to my lambda, you'll see that it has H.264 at the end. So that's why I do that. By default, the URL that's kind of generated to be able to talk to the RTSP stream has /proxy stream at the end. I wanted /H.264, and I do it in this particular file. I also bump up the buffer size from 1000 to 5000. It's only one instance, or actually no, 10,000, 100,000, whatever it is. That number, I just timed it by 5, and I then build the live55 software. This environment is actually, I'm going to delete that, it's of no interest whatsoever, and I expose port 443. Now if I do that docker build command, I think it's just not going to do anything because I've already built it. But if you do that, it'll run everything, from that docker the first time anyway, from that docker file. The magic of Docker is that in principle I've done the hard work for you. In principle, you can take my docker file, which I'll put in to GitHub, and just run docker build, and it'll do all the configuration and stuff that I worked out how to do. None of it's particularly complicated. It just took some time to get it working. Once I've done this, I said I was going to look at the stunnel file. This I essentially, so it takes or uses the PEM files that I generated using certbot, and I copied into the Docker image you saw here, certs. So if your files are generated using different names for some reason, you'll want to change those. These ones here I didn't do anything with. These are just ones I copied from one of the blog posts. And that was it. That's pretty much it. It's saying listen on port 443, but actually connect over to port 80. So it's talking to the live55 server that's running inside the Docker image. So this is how I run the Docker container. Oops, that's not how I do it. Let's see if I can copy paste it from my Evernote note. Alright, so what's this doing? It's running interactively. It's saying expose port 443 from the container to the outside world. It's running that Docker image that I built using docker build. It's saying run bash using these parameters. First thing it does is run stunnel, which runs in the background as a daemon, and then it runs my live55 proxy server that I built when I did the Docker build. -v says give me verbose logging, and it talks to the Nook media server that I have running, that's running the security camera software, and we'll look at that next. So it talks using, if you'll see, it talks, so it's called Nook 7 i7.lan. That's the internal domain name inside my firewall for that Windows machine that's running the security software, and it's saying use port 8554 and the path /1. So how did I get to that? Well, I'm going to use Chrome Remote Desktop to look at my security camera. So this is my Windows machine running my security camera software. You can run anything you want to. There's absolutely nothing linked. It's just remoting this screen. So you could be doing anything. You could be streaming Netflix. You could, whatever you want to, I guess. You know, you can remote this screen over to your Echo Show as a security camera. And so I run this. So I've installed VLC, which you'll find on the internet. I go to the VLC directory, and I run this command. So I say I want to stream the screen. Not sure if I need this sout keep. I spent so much time trying to configure this to get it to run fast and so on, and so anyway, so you may or may not need that. And I'm saying I want to use the H.264 codec, which is what the Echo Show needs. No audio codec. Again, I probably could do something. Scale the screen by 0.5. Actually, I'm going to kill it. The VLC instance that I already have running. So anyway, scale the screen by half. So this screen is whatever I put in. If I just go back to my Visual Studio where I defined the screen resolution, so the screen is actually 1920 times 1080, but I halve it, and that's why I'm in the lambda. I say the resolution is half of what the X screen is actually, because when I run the VLC command to stream this screen over RTSP, I say I want to scale it by half, and this is the endpoint. So remember, in my Ubuntu, if I just switch back to that, I said I wanted to connect to RTSP Nook 7 i7.lan 8554/1. That's what. Sorry, here we go. That's where this is here, 8554/1. So I didn't have to do. I'm not running any special software on this Windows machine, and like I said, I'd expect this to work with a Mac as well. I just installed this VLC command, and then when I run that, it spins up VLC. You can see it ticking away in the background, and you minimize it, and away you go. And you can see the leaves falling because it's autumn time, and we have pumpkins outside our house because today is the 5th of November. Remember, 5th of November, and so 2017, and so that's I can't imagine anybody's looking at this a long time in the future because technology moves so fast. But anyway, those are my security cameras sitting outside, and anyway, that's that. So that's, I think that's pretty much everything. Is there anything I've missed? I don't think so. Let's just go back to the presentation. So I think that's it. The big picture is I say Alexa, discover smart home devices. Using my skill, it talks to my lambda that says I have one security camera, and it's called security cameras, and it's got this resolution, and that's pretty much it. You know, it's got this ID and so on, and it comes back to this, and then I say Alexa, show security cameras, which is the name I've given to the security camera, the virtual security camera I've kind of created. And what that does is it talks to the lambda, which returns back the URL of the Ubuntu server using SSL port 443, and so it returns that URL back to the Echo Show. The Echo Show talks directly to my Ubuntu machine, so it's using the LAN. That's why I put the IP address of the this machine as we've gone with regards to the LAN, so 192.168 blah blah blah, in the DNS. So anyway, it talks to that, and it essentially is talking to S-tunnel, which is wrapping the proxy server, which talks to the VLC instance running on this machine here. If I just go to my browser, there were a couple of things I wanted to mention. I think I've got all this stuff. My blog, damien.fyi. This is where you'll find all the details. You'll find this image, this video, and plus other things I've not posted it yet. Plus got pointers to the GitHub, my GitHub repository there, Damien Mears. You'll find the code, the Docker file, and the lambda code in there. And I am on Twitter if you feel like following me, at Damien Mears. I don't just post Alexa stuff. I also write a lot of stuff around Xamarin, which is a C# technology that lets you write native apps on iPhone and Android, which you probably don't care about in the slightest. But there we go. That's my day job. There we go. I think I'm pretty much done. Don't hesitate to contact me. A lot of this stuff I worked out as I went along, so I'm not an RTSP guru. I'm pretty comfortable around Docker, but I'm not, I don't live and breathe Docker. I don't live and breathe Amazon Echo. So I'll try and help you if I can. Best way is probably comments on the YouTube video or comments on my blog. Actually, comments on my blog might be best. But I'll do my best. But kind of prerequisites for working out how to do all this stuff is to read up on defining an Echo smart home skill, read up on lambdas, read up on Docker, and you should be good. Alright, not a very fluid ending. I hope this has been useful to you, and it's pretty straightforward. There's a lot of moving parts, but it's pretty straightforward. Thanks.